Hello everyone, welcome to my second part of integration. In today's video, I will go through the definite integration. Right, so integrals of non-polynomials. On last video or last lesson, I went through the integration when we have polynomials where we have integral of many terms and how we can just apply the rules of integration. We add 1 to the power and we divide by the new power and we add c at the end. Yeah, so just for an example, just to remind you, if we have the integration of x squared plus 3x dx, then the integration for this, we will add 1 to the power, so it's going to be x to the power 3 divided by the new power, which is a 3, plus 3x squared divided by 2 plus c. So this is the polynomial function, which means different terms. We add them together. Okay. So in this slide here, we have the integral of e to the power x dx, and e to the power ax is exponential function. The integration for the exponential function, it's stay as it is, same as e to the power ax, and you just divide by the derivative of ax. Okay, so that's why we have 1 over a here, and plus c, because this is indefinite integration. So that means there is no limits for the integration. So we have to put plus c. So the exponential curve is unaffected by integration. And we don't need to prove any of this in this module FC309. Okay? Right. So we can also integrate other non-polynomial functions like the sine, cosine, and the tan. And as you can see here from the table, the integral of sine ax dx is minus 1 over a cosine ax plus c. I'll just show you that why. This is the table again. Just go here, right? If you just make a list, or if this will help you, this method, if you write sine x, cosine x, just put them in order, then minus sine x and minus cosine x and sine x again, right? And if we take this, the order from the bottom down there, from below to the top, okay, and this is going to be the integral of dx, and the other side is when you differentiate from the top to the bottom. So this is dy over dx. So for now we are working on the integration, the blue part here. So how to work this out? It basically means if you move from down below here to up there, yeah. So the integration of sine x is minus cosine x. What's the integration of minus cosine x is minus sine x. The integration of minus sine x is cosine x. Integration of cosine x is sine x, and that's it. Okay, and the same way for the derivative, for the differentiation, you move from the top to the bottom. So basically the dy over dx for the sine x will be cosine x. For now, we are talking about the integration. So I'm just going to write some of them for you so you will have the idea. So the integral of sine x dx equals, so the integration of sine is minus cosine x plus c, right? If we have integration of sine 3x dx then the integral of the sine is minus cosine. Yeah, so it's minus cosine. The angle here, like the sine, it's sine for 3x. So it's going to be minus cosine 3x as it is, then plus c. Right, another one, the integration of minus cosine x. Well, let's make it 5x dx. Okay, sorry, I forgot to divide on the previous one. We need to divide by the derivative of 3x. So we divide by 3 here. All right? Okay, for this one here, minus cosine 5x dx equals the derivative of the minus cosine, yeah, is minus sine. Yeah, just go up here. So it's minus sine. So the derivative of minus cosine, the integration of minus cosine is minus sine. So it's going to be minus sine f5x, and you divide by the derivative of 5x, which is 5, plus c. Okay. Another example, the integration of minus sine 6x dx equals, so the integration of minus sine is cosine. So this is going to be cosine 6x divided by 6 plus c. All right? I hope that's clear now. Okay, let's go back to the slide. So, integral of sine ax dx equals minus 1 over a. That's the derivative of the ax, multiplied by cosine ax plus c, and same as I explained on the other page about the sine and the cosine. For the tan, it's 1 over a. Again, this a here, like we are dividing by a, which is the derivative, yeah, of the ax, which is we divide by a. Okay, so this can be written as same thing. It's same exactly. It's we can write it as ln cosine inverse ax, ln cosine ax. Yeah, so cosine inverse ax over a plus c. So cosine inverse means 1 over cosine, or we can write it down as minus ln cosine ax minus ln, and again minus ln cosine ax with inside a modulus plus c, and this is divided by a. Okay, because this is the derivative of ax. Right. Again, you don't need to prove how you reach this, but if you want, it's in your book as well, page 343, if you want to look at it, how the tan becomes as minus ln cosine ax plus c divided by a in about your question. In the book, it's just x without ax, but it's the same thing. Okay, this is the table, basically. Again, it's same. The first one here is showing like ax to the power n dx equals, so that's if we have, for example, integration for x squared dx. Yeah, so this is going to be, we leave the 4 as it is, no problem, and the x squared will become x cubed. We add 1 to the power, and then we divide by the new power, which is a 3, and plus c. and then we can simplify it, of course, but I'm just showing you like what does that mean, and the rest we just went through it already. Okay. The rules of integration here. Integrals obey the scalar multiple law. That's just like means that for any scalar number k, any like k could be any number. If we have integration of a number multiplied by a function, so this is a number k multiplied by this function f of x dx, then we can take the number outside the integration and we integrate the function as it is. Just quickly an example, if we have the integration for 9 x squared plus 4x dx, then what we can do, we can take the 9 outside and write the integration as x squared plus 4x dx. And then we can integrate, carry on. Okay, same thing, the integral of two functions added together, like f of x plus g of x dx, it can be separated into two separate integrals. Like as you can see here, this is the integration or integral of f of x plus integral of g of x. And same thing apply for the subtracting. So if we have integral of f of x minus gx dx, then again we can subtract to make two separate integrals. So integration for f of x dx minus the integral of gx dx, and we work it out. Integration and area here. The important application of integration is to find areas. Okay, so it's important to find areas and volumes as well. In fact, many of the formula that we know for calculating area and volumes are found using integration. So consider the graph here in this slide. The shaded area, the green area here, it's you can see this shaded area, it's under the function, under the curve, the red function curve here. And as you can see, it's bounded by the x-axis and the two vertical lines where the values of x, one of them a and the other one b. And in this example, x is 0 and the other value is 1. So this shaded area is under the function. It's under the function and it's bounded between the curve, the x-axis, and these two points on the x-axis. Okay? And for now, on next video, I will explain how to find the area under the curve or under the function. For now, just we want to go through the definite integration where there is a limit. So this is a limit, x equals 0 and x equals 1. These are a limit of the integration, basically. So the definite integration, it means that we can see on the integral sign here, we have limits from a to b. Okay, so usually the lower number is at the bottom and the higher number at the top. So the integral of f of x dx, or maybe you see it as the integral of y dx, both of them, it gives, when you integrate the function with the limits, can give us the area under that curve or under the function. And the area, it will be only between the curve and the x-axis and the lines where x equals a and x equals b. So as you can see here on this graph, the area shaded in blue, it's bounded between the curve and the x-axis here and these two lines where x equals a and x equals b. All right? So provided that the curve lies on or above the x-axis, so the curve should be either on or above the x-axis, because to find the area need to be positive. Okay, if it's under the x-axis, there is another thing we need to do. I will explain that on the next video about finding the area. Okay, so on this example here, find the area bounded by the curve fx equals a 3x squared plus 2, and the x-axis and the vertical lines where x equals minus 2 and x equals 1. So the lower limit is minus 2 and the upper limit here is 1. Okay, so the integral of 3x squared plus 2 dx, so this dx basically is for all the terms here. All right, now when we integrate, this is polynomial terms function. So when we integrate, we add 1 to the power and we divide by the new power. So this is going to be 3x cubed divided by 3 plus 2x, and we don't write plus c here because we have limit. We put the limit from minus 2 to 1. We can cancel down, so we have this 3 and this 3, they go together, and we end up with x cubed plus 2x and bounded between minus 2 and 1, right? Now what we need to do on this step here, what they are doing here, replace each x by the replace each x by the upper limit, which is 1 here, and minus replace x by the lower limit. So basically this will become x to the power 3. So this is going to be 1 to the power 3 plus 2 times 1. Okay, so that's replaced by each x by 1, minus replacing x by minus 2 in this time, and this is going to be minus 2 to the power of 3 and plus minus 2 to the power minus 2 to the power of 3 plus 2 times minus 2, okay, which is this step here you have. So this becomes like 1 plus 2 minus, this is minus 8, 2 times minus 2 is minus 4, which is minus 12, and that's why we got 3 minus 12, which is a plus 12, so this gives you 15. Right? Next example, we have find the area bounded by the curve fx equals x squared minus 7x plus 12, and the x-axis and the vertical lines where x equals minus 1 and x equals 1. So the lower the lower limit is minus 1 and the upper limit is 1. So in this case here, again, it's we have a few terms, the 3 terms added together, so we can just do the basic integration. We add 1 to the power, we divide by the new power, so that's the x squared, we add 1 to the power, so it's x cubed divided by 3, minus 7 x squared divided by 2, this is the new power, plus the integration of 12 is 12x, so plus 12x, and the limit from minus 1 to 1. Now we replace each x by 1 first, yeah, so that's here when x equals 1, and then we replace in the other bracket here, we replace each x by minus 1, all right? So this is 1 cubed over 3 minus 7 times 1 squared over 2 plus 12 times 1. okay, minus this another bracket where is minus 1 to the power of 3 basically, and it will give us minus 1 over 3 anyway, minus 7 over 2 times minus 1 to the power 2, like 7 minus 1 squared divided by 2, minus 12 times minus 1. So when you work it out, this is multiplied by minus 1. When you work it out, will give you this answer. And I work it out in the next slide for you. So I work it out here in this slide for you to follow the steps step by step, if that will be helpful for you. Okay, there is this picture from your book, page 116. Find the integral in the normal way, but use the notation above here, which is the integration. It is a definite integral here. So if you just go through it, read these examples, and then there is exercise 2.1, page 116 as well. If you do some questions of this just to practice your work, like how to do that question, and you can always check your answers at the back of your book. If you have any question or if you need to ask anything, just let me know, and I'm very happy to help you with that. Okay, so that's it for this video. This is the end of this lesson, and I'll explain the finding the area and the recurve in my next lesson. Okay, take care and goodbye.